Okay, this is M1 Jan 2005 question 7, and we've worked out in the part A that you've got P is travelling with a velocity of 3I plus 8j. That is to say that it's starting 20 kilometers to the right and 10 kilometers up. Yeah, so it starts there. Okay, and every hour it moves 3 kilometers to the right and 8 up, 3 kilometers to the right and 8 up, 3 kilometers to the right and 8 up, and it keeps doing that every hour. So if I wanted to work out its position after 4 hours, I would have to do, for when t equals 4, I'd have to go, well, you started off here 20I plus 10j, and you'd have to add 4 lots of the movement, yeah, which would be 3I plus 8j, and so we get an expression, okay, which is this. So the actual kilometers, we can also do it in column notation. So 20, 10 plus 4 lots of the movement every hour, 3 to the right and 8 up. Okay, and that would be in kilometers. Okay. Now, if we want this expression of its position at any one time, then instead of having a specific t equals 4, I'd say for any t, okay, I just get the expression 20, 10 plus t lots of, and it doesn't really matter which side you put the t, but that's the position of p. And so if instead of 10 hours, for instance, you'd have the original starting position. So I made a mistake. That is supposed to be 20. That is actually a 2. In 10 hours, it would have done, just looking at the x, it would be 20 meters to the right, and then it would have done 10 lots of that 30, so it would be 50 to the right. Okay, so this is our expression for p at any given time. Now you can see q here starts off 14 to the right and 6 down. By the way, this is your y-axis, this is your x-axis, and every hour, okay, it travels. Okay, I've put in the velocity as 0I to make it clear that you're not travelling left or right, and every hour you're just moving 12 up, moving 12 up, moving 12 up. Okay, and so when t equals 3, okay, 3 hours later, if we just look at the x, okay, well, nothing happens to the x, so the x stays the same the whole time, but I will have moved 36 up. Starting position was -6, so after 3 hours my j would be 30j, so I'd have 14I plus 30j. That's at when t equals 3. How did I get that? Well, I had my starting position, which was 0 minus 6, and then my movement is 0 on the x but 12 on the y, and I've just done 3 lots of that. Okay, 3 lots of how much you move per hour. Okay, and so my position at any given time for q is given by the formula my starting position plus how much I move every hour. Okay, so that's how we get the starting position of q and p. Right, so that is basically how you get those two equations that you questioned. Okay, the next thing we have to do is we have to work out an expression for the distance between these two vectors, and you can see at t equals 3 I've got q being roughly here and p being roughly here, and if I was just to draw that here, then you can kind of imagine that's q and this is p. We're in some position here, and I want to find the vector p to q. So p to q. Okay, well, to do vector p to q, I'm going to do minus p and plus q, going that way and then that way. So that gives me q minus p. And what I'm going to do is write those expressions. So you see that q was 14. Well, originally the whole of this expression p